Live bees arrive 5 days a week at the University of Maryland College Park campus and are immediately placed into an ultra-low temperature freezer to help preserve the delicate genetic material required for viral analysis. For each individual box, a portion of the now frozen bees is collected into a 50 milliliter sample tube to allow for easy storage and use. The tubes of frozen bees are then transported to the USDA Bee Research Laboratory in Beltsville, Maryland, where the RNA extraction and polymerase chain reaction viral detection are completed. The process has many steps to ensure the generation of high-quality, accurate results. From the sample tubes, 50 bees are counted out. Those 50 bees are then placed into a special bag that is necessary for the next step when the contents of the bees' cells will be collected. Liquid nitrogen is used to freeze the bees to an even colder temperature. The special bag is capable of withstanding extreme cold and is placed directly into the liquid nitrogen. When the bees are frozen to this extreme, they can be pulverized using a pestle, creating a dry mashed sample from all 50 bees. Before the contents begin to thaw, a buffer liquid containing guanidine isothiocyanate is added to the bag. The buffer is used to stabilize the genetic material and begin the process of cellular lysis when the contents of the cells are released and homogenized into the mixture. The bag is compartmentalized to allow for the collection of the liquid without retaining the debris. This cellular crude extraction is used for the next steps when the RNA molecules are isolated from the rest of the cellular contents. The machine used for the RNA extraction is prepared, making sure it is stocked with the necessary pipettes, buffers, and molecular extraction filter columns. A portion of the crude extraction liquid is added to the RNA extraction machine, along with up to 11 more samples per extraction operation. After the operation is complete, all that remains is the RNA material originally contained in the 50 counted bees, now suspended in water. The concentration of RNA material in each extraction is checked using a spectrophotometer, and each sample is diluted to a consistent standardized value. The polymerase chain reaction used to detect the viral targets can now be prepared. A master mix containing all of the components necessary for the amplification of genetic material is created for each individual target. An aliquot of the master mix is added to each well of a PCR plate. Then the diluted RNA from each sample can be added to an individual well of the plate. Each well on a plate allows for the detection of a single target for one individual sample. The plate is sealed, centrifuged, and loaded into the PCR machine. The polymerase chain reaction begins, and once completed, the results for the samples run are ready to be compiled into a report for analysis. About 1,000 reports are generated every year. To reduce costs and waste, multiple samples are processed together. During the peak season, more samples are received than can be processed on a single PCR plate. This video, although complex, is still a simplification of the actual process and represents only one aspect of your final report. Thank you for watching.